Hello, folks. Welcome to Rational Science. I'm a little over my cold. I had a little stuffiness there, lasted 10, 12 days. Fortunately, it's gone. Anyways, we have a great day today. We're going to be talking about spin, whatever that is. Um, I hope I'm doing fine here with the video and the sound. Okay, let me know otherwise. And so let's get started. I'm going to start again with extinction. Extinction segment. We're close to extinction here on Earth. We are the last generation of humans on Earth. That's what we say in this channel. Okay, you're welcome to challenge us. Okay. Anyways, let's start with this. We have all these wars going on. We have Ukraine versus Russia, Israel, Hamas, China, Taiwan, Azerbaijan, Armenia, North Korea, South Korea, India, Pakistan, and I'm sure there's several more. And my only recommendation to you is don't pick sides. Okay, what are sides? Well, they're just mafias. Okay, and you know, the people who rule the planet, they don't care about the petty people out there, the ones who go out into the streets and burn tires and break windows. Those are the fanatics who choose sides. These people don't care. And, there you have a scenario. Should you choose Bugs Moran over Al Capone? I mean, which mafia do you think is better? Okay. And so that's more or less what it comes down to. I was recently in Jordan, Amman, and it was funny. The prince got married, Hashemite with a Saudi. They're trying to unite the crowns, sort of. The wealth. The rich marry the wealth. The rich marry the rich, the wealthy. And turns out that you see there that there's a problem here. We have a war between Israel and Hamas, right? And an invasion, whatever you want to call it. And it turns out that all the Arabs are up in arms. They're all upset, right? And what did the leaders do? And this gives you a little focus on what's really happening. All the people out there, they choose sides. They say, oh, this is injustice, and that should be like this, and that should be like that. And what do the rulers, the people who rule, do? Well, Jordan and a couple other countries, Turkey, etc., they're so upset, and they recall their ambassadors. They say, "Oh, this is an outrage. We're going to recall our ambassador." Sounds very cosmetic. It's like, let's throw a bone to the dog there. Keep them happy. You would think that under a situation like this, where they're killing people, these people would be a little more adamant and say, we're going to cut all commerce with Israel. And you have all these Arab nations cutting all their commerce with Israel. Not one of them did so. They're all recalling their ambassadors, which is very cosmetic, which is nonsense. Because as soon as this war ends or whatever, because it's going to end someday, I'm sure, well, they're going to put their ambassadors right back in. But see, they didn't cut their economics. They didn't touch their economics because it hurts them as well. They'd be shooting themselves in the foot. So they only give lip service to this whole thing, and then they try to figure it out, in close quarters, how they're going to solve these things. So my suggestion is don't take sides. That's what I learned from politics. Don't get involved with politics. Okay, there's one site. There was an article, and he talked about the end of humanity. Humanity will wipe itself out, right? And the Sci-Fi put this article that was published, and it's got this notion that the 14 most likely ways that we will disappear, right? And the problem with this whole thing, with this whole approach, is they looked at all the relations, between technology and, different things that we have out there, and they put them all together, and they say, well, these are the 14 things that we think may cause the extinction of man. And as always, they have hope that maybe we can fix these things as long as we're aware right? That of what the problems are, and maybe there's a way to correct them. Even though they start by saying that all species eventually become extinct, it's like, yeah, but since we're smart, we're intelligent, we have technology, we can foresee the future. Maybe, just maybe, we can avoid it somehow or postpone it. Who knows, another 1,000 years or whatever. And so they missed a boat. These people are saying essentially that there are all these causes, but they missed the main one, which is the collapse of the global economy. That is a guaranteed way of killing man. Right now we wouldn't be able to survive if we didn't have commerce, if we didn't have trade, if we didn't have money. And just imagine if God waved his magic wand. Oh, here I've got one magic wand, right? God waving his magic wand, and suddenly makes money disappear. And by that I mean that people no longer believe in money. They don't accept money, and so you can't give them money. You got to give them something a little more solid, than money. And this is the issue. The issue is if we can make money disappear, even by magic, right? What would happen to humanity? Well, I can guarantee that we would all die, because without trade today, right, humanity cannot last. We need money, we need trade, we need commerce, okay? We need to trade stuff, exchange. That doesn't happen, well, we do not receive food. And just about nobody produces his own food. Everybody goes to the store and waits for someone to put something on the shelves. It appears apparently by magic, because you just go to the store with money, right, with bills or with a credit card or debit card, whatever, and they give you food. Are people stupid? They're saying, hey, I'm giving you something real, something you can use like food, and you're giving you what? A number in a bank account? What the hell's that? Well, the only reason they accept that is because they can do something with that number. They can pass it on and buy a car or whatever. But imagine if people suddenly realize that that's just a number you gave them. You're on an island, and one guy's got a banana and the other guy's got a number. Let me give you a number for your banana. I don't think it would work. So money can only subsist under certain conditions. And I think that's what's going to happen. Money will disappear because the global economy cannot grow forever. At some point, there's going to be a crash. It's not going to be a simple recession or depression. It's going to be extinction. That's what it's going to be. Without economics, we're all dead. Anyways, here one fellow says, you said that Calhoun, referring to John Calhoun, who did the experiments first with rats, then with mice, that was the first to create homosexuality in the lab. Yeah, one of the first, I think. There's a couple other experiments out there, one with fish that I know of, so you got to look around. But essentially, Calhoun created homosexuality, and you could say autism as well, in the lab, okay? Or in other words, homosexuality induced by human intervention. I disagree, as prisons have been around since way before Calhoun, right? And prisons induce homosexual behavior, and we know for certain why this is. Okay. So are we certain that the enclosed conditions and lack of available mates of the opposite sex didn't contribute to these conclusions? Well, what can I tell you? First, I want to address that prisons induce homosexual behavior, and we know why that is. Well, I don't know where you got that. I've been through at least 7 prisons in my 3 years in the slammer, and no problem. I found all kinds of people in there, and essentially it's a microcosm of the people out in the free world, right? There's very little difference. And I think you could safely divide people inside the prison in 2 halves, general, that's just a rule of thumb, okay? And that is that half the people hate them and despise homosexuals, and the other half tolerate them and say, well, that's their business, I don't care, you know. So that's more or less the attitude that's in prison. Now, I just want you to think about something. You go in prison and you find this gang, right? And the leader of the gang says, I think I'm going to have sex with the next guy who comes in here. What do you think his gang members, you know, his bros, what do you think they would think about him? They say, oh, you want to have sex with a man? That's what they would think. So, no, this thing that they rape you the first day that you come into prison, you know, it's a myth. Okay? It doesn't happen. Sex is not that great in prison. And so what happens is that, you know, the authorities, they want that myth to spread. They want you to believe it so that you're a nice guy and don't go to prison. Okay? That's more or less, it's a deterrent, right? But no, I don't know where he got this thing that prisons create homosexuals. Homosexual, the guy is born that way, and you know, I don't know why anyone would say anything different. If you see a Down patient, you know, Down syndrome patient, everybody looks at him and says, "Well, he was born that way." You know, they didn't make him in school or at home like that. You know, teaching him to be like that. He was born that way. But when we get to these other things like homosexuality people or autism, they say, well, you know, that was schooling. Why would you change that? What's different? You know, and that's what you got to show. You got to explain what is different between, you know, being homosexual and being a Down patient. Is there a difference? Isn't this a mental disorder? Well, the psychiatry and psychology associations of America, they said in 1973, and the other one I think was 76, they ruled that it wasn't a mental disorder and they took it out of the books, out of the mental disorder books. But why? Why did they have to do that? Because there were so many people coming into their office say, cure me, doc. I got a problem. Yeah, I'm homosexual. Oh, you're homosexual? Yeah, and so please cure me. What was the doctor going to do? What was a psychologist or psychiatrist going to do? Give him a shot in the arm and say, okay, you're cured now? You know, there was no cure for this. And there were so many, they flooded the psychiatrist offices, and they finally just said, hey, this is very easy. We're just going to say, this is not a problem. If you can live with it, you're okay. And if you can't, well, I don't know, maybe you commit suicide or go to some kind of care, you know, association takes care of you guys, you know. So that's the way they handle it. So now you got to show, you know, why this is so. Why, you know, the question is, why do we have so many homosexuals today? Is it that suddenly they came out of the closet because there's more freedom, there's more information, or was there a real problem, you know, where they invaded the psychiatrist offices? And they said, and then the psychiatrist said, hey, you know, there's a flood here. We got to do something about this. And very easy. They said it's not a disorder. That's how they solved it. And so today we don't have these as mental disorders as they used to be. Okay, another fellow talking about similar subjects says, about Calhoun, why did the mice stop breeding? Okay, I think it was because the mice got stressed out. Okay, they didn't become autistic. They just moved away from all the fighting. Okay, you can really mess animals up by raising them wrong. Interactions with their environment cause physical changes in the brain. But you got to tell me the mechanism. All you made is a statement. Said, you know, environment causes these mental changes. Okay, person now thinks in a different way. What's the mechanism? How did the environment change his brain? That's what you got to kind of explain. If you can do that, I mean, I'm not saying it's something you're going to think about in 2 seconds and come up with an answer. You really got to get down to this because you're saying that the environment somehow induces changes in behavior. Okay, so we got to figure out how that is so. You know, density in this case, right? So what I can tell you is lack of genetic diversity is nature. Okay, that means we're born that way. If there is lack of genetic diversity in the entire human race, as I've argued in the past, where, you know, I argued that we have a troop of chimps, and they have more genetic diversity, maybe 100 monkeys there, they have more genetic diversity than the entire human race, 8 billion people. You got to explain that. Why is that so? And the question is, again, science is about explaining. You got to explain the cause, okay? What caused that to happen. And then you have environment, and that's nurture. It's schooling, it's how you were raised at home, influence from society, whatever. Okay, so we would call that nature versus nurture. Okay, mice and rats did in fact become autistic, or as Calhoun said, he said they stopped being mice. Okay, for the mouse, the mice group said they stopped being mice. What he meant by that is these mice were kind of like dumb. They were just in one corner. All they would do, come out, maybe eat, and then go back, right? They were chased by some of the other mice who'd bite their tails and made them bleed and so on. But these were stupid mice. They're not the mice that you find out there in the fields or railroad tracks that move around. They're smart and they're worried about their environment, who might attack them, who they can attack, etc. These mice were just complacent. And in a sense, you can see why. If these mice did not have to struggle for food or water, they were given all the food and water they wanted. They had all the nesting material, etc. They had no predators. So you develop different kind of mouse. But the issue here is whether this mouse, right, is made through nature or nurture. Because all these mice, we're talking about the last generations where there was high density. That part is nurture, but they all come from the same grandparents. You have this founder's effect, and so the question is, did that cause the mice to be different? Okay, was it genetics? In other words, going inside their body, and how much of each? You could also discuss that. So you got to look at the whole picture, not only say, oh, it was the food they ate or the density. Density obviously was a factor, but what about the genetics, the fact that they all descend from the same grandparents? And so, yeah, again, was it nature, nurture, or both? That's what you got to kind of resolve. Okay, and you should keep all the factors in mind, not jump to conclusions. Okay, just go in there and say, okay, what could have caused all this? Okay, so here we have more on autism. Okay, a fellow says you should explain autistic psychology before telling us what causes it. Autism and retardation aren't the same thing. They are both side effects of mutational load. Okay, and well, what can I say? I'll put this up here. And that is that science, we deal with rational explanations. And we separate physics from philosophy, the only two branches of science. You either do physics or you do philosophy. Physics deals with objects, causes, and mechanisms. Philosophy deals primarily with concepts, reasons, and purposes. You want to know why someone did something, why someone behaved in a given way. And so when these people bring up these subjects, here we only do physics. We do not do philosophy. Philosophy, we don't explain reasons and purposes. At least that's not what this channel is dedicated to. Sometimes we touch upon the subject, but that's not our main course. Our main course, by far, is physics. We want to see how the physical world works, okay? And so, yeah, when it comes to autism, you got that situation where you say, how much of it is nature, how much is nurture? Nature would be physics, nurture would be, philosophy. And so, again, we got to start at square one. Is autism a consequence of both? Okay, or is it primarily, that we have it in our blood because we are the last humans on Earth? We've been inbreeding for 200, 300,000 years since Adam and Eve came into the record. So we've been inbreeding for a long, long time. And we're 8 billion people now. We all come from those same predecessors, right? So the question is, does this inbreeding produce effects in the long run? And that's the question before you. That's the one you got to answer. That's the way I look at it, at least. Okay. Here's another fellow says, when one researches autism rates by country, it appears that every study has conflicting results. No research groups can agree on the data, so is it reliable? Well, we don't want to throw the baby away with the wash water, okay? We've been collecting data for autism for a relatively short time, maybe a few decades. And before that, nobody cared that much about that subject. It's a subject that has grown in importance. And I think in partly because we have more children coming out with autism and attention disorders and who knows what else. And the question is this, again, a consequence of density? Is it the education at home? Or is this something we carry in the blood? Is this related to the fact that we've been inbreeding for so long and that we've washed out our genes, our genetic diversity? Okay, so again, it all comes back to that question. Not easy to answer. I'm going to say this is something that you're going to wake up one morning and say, I got the answer. But you got to do a lot of research and on both ends of it, not only on the density and education on the nurture part. You got to look at nature as well. How much of this comes inevitably in our species because we've been inbreeding. It doesn't happen to all species, and I say it does. It does. You find a lot of this stuff among lions, sheep. Homosexuality, you'll find it among sheep and lions. And I'm saying this is something new, partly because we have much fewer lions today, so they can't avoid inbreeding at an extreme level. That's one issue. But the other one that strikes in my mind is, we used to have lions, especially when they brought them into the Roman circuses, the Colosseum. And so they used to know a lot about lions, or they've seen lions, and nobody, I can't say all the way from the Romans, but at least maybe a few hundred years ago, nobody ever mentioned that lions were having sex with lions, male with male. And this appears to be something new, and that would explain, partly not because of density, but because of lack of mates. We had about 150,000 lions in the world, primarily in Africa. What was it, in maybe 40, 50 years ago? Now there's only 30 or 35,000. So the population has been dwindling. And that means that now you have almost no choice but to have sex with a cousin. Okay, so I think that's part of the problem. Okay, now a fellow talking about autism says, autistic brains are about 3% larger. However, for whatever reason, this doesn't really translate to higher IQ. Okay, the problem here is this IQ issue. The IQs really have a lot to do with, how much you study, because you're going to be doing some math, you're going to be doing some of these things that you learned, not that you were born with. So it's not testing your, innate intelligence. It's kind of testing what you've learned in some cases. And so the question really comes a little early, and is, what is intelligence? And there I show the plant cell versus the animal cell, and I'm saying that any cell or the cell itself is a synonym of intelligence, because it's compartmentalized. Okay, it's it has a CPU, it has a center that governs all its parts, and I think that's the best way to define intelligence, along those lines. And if that's so, even plants have intelligence, but the question is, people usually think of intelligence as something that's unique to humans. We have intelligence, nobody else does. Animals don't have intelligence, neither have plants. And so the question is, what do you mean by that? Are you saying the lion does not have intelligence? I mean, he's got a certain type of intelligence that he needs to do his daily work. He's got to hunt. He's got to figure out how he's going to catch that animal that he's going to be eating. So I guess he's got some kind of intelligence. Okay, he has a sense of timing. Okay, he's got a sense of time. He doesn't carry a watch, wristwatch, but he knows how fast he is and how fast that animal runs, and so he more or less calculates, intuitively says, I can catch that guy. And that's why he runs. Otherwise, he doesn't take the trouble because it's too far away or too fast for him. And so what is intelligence? You have to define it first, and it's very hard to define intelligence, believe me. That's why I like to define it at the root. I'm saying that if it's just a CPU, something that governs, certain parts of itself, I think that's the rudimentary definition of intelligence. Okay, subject here, different. Fellow says, I'm not saying that chickens are dinosaurs, but that there are still dinosaur traits. Okay. Okay, so the question, a lot of people say, well, dinosaurs are still around. They're what? They're still around? I didn't know that. Better watch out, when I walk into those alleys, And what do they mean by that? They mean that, the birds are descendants. They think of them as descendants or as cousins, or who knows what goes through their mind. They think that birds and dinosaurs are more or less the same thing. And here you have one article, at least, that vouches for that. It says, are birds really dinosaurs? Is it disputed? It says, there's no longer really any doubt that birds are a type of dinosaur. These days, the debate is about details. The strong evidence doesn't just come from fossilized bones and similarities found across the skeleton, but from fossilized soft tissue. Okay, and it goes on and on. It says, birds belong to the theropod group of dinosaurs that included T-Rex. So they're theropods, right? Theropods are all bipedal, and some of them share more bird-like features than others. And they go with Archaeopteryx, discovered in 1861. They go Velociraptor, and there's a couple more, okay? And so the question is, are birds, they put these claims out there, and people start saying, oh, the dinosaurs are still around because they're flying now. And so the question is, are these dinosaurs? Are birds dinosaurs? Okay, and that's the question. So you can say, some people say, well, the dinosaurs never became extinct because they're still around. They're flying around now. All these T-Rexes, these theropods, they're flying around. Okay, so here we have some of the early birds. Okay, you got there 160 million years ago. That was towards the end of the Jurassic, and then you got some 125 million years ago, maybe beginning of Cretaceous. And you had these birds. Did these evolve into you could call these the dino birds? Here are the reptibirds, reptiles, flying reptiles. Some of these apparently had feathers as well. And so the question is, are all these dinosaurs? Birds and anything that flies, are they dinosaurs? And I think we have to distinguish, certain types of animals out there. What if I told you that you're a synapsid? Synapsids were around at the beginning of the Permian all the way to the end of the Permian, and they were gone forever. And so are we mammal-like reptiles, as the synapsids are also called? And so here's the question for those people who say that birds are dinosaurs. I'm going to say that then we're also synapsid for that matter, right? Because does your mother look like any of these? Are these the ones that are in your family? These animals, the Dimetrodons, the Parasaurs, they disappeared. Sometime during the Permian, the Dimetrodons disappeared first. Parasaurs towards the end of the Permian when the Triassic started. And so the question is, are we going to say that we are synapsids simply because we share some commonality with them? Those, those tiger-like animals or lion-like animals, they laid eggs. Have you ever seen a tiger lay egg? Have you seen a wolf lay egg or a bear lay an egg? And so, yeah, we have some features in common with the synapsids. That doesn't mean we are synapsids. And to say that birds are dinosaurs because they share some features with them or had a common ancestors doesn't mean that they are dinosaurs. Dinosaurs is a different order than birds, okay? So it's wrong to say that birds are dinosaurs, first of all, and it's, all these paleontologists, they want to be in the news and they want to say these, exorbitant statements, make these tremendous statements saying, oh, yeah, the birds are dinosaurs. And people say, oh, wow, they did a study and they showed that they're the same. Now, that's just to create the oohs and ahs and get their name in the books. What you need to look at is, that they had a common ancestor. That doesn't mean birds are dinosaurs, and neither are we, synapsids. Okay, and so, you got to look at these things, not jump to conclusions or synthesize so swiftly, okay? Reach these general concepts, these general verdicts or whatever, conclusions. Okay, so here we have, Paul says, life after death is a classic oxymoron. Life and death affects all animal forms, including parasites and bacteria on all planets in the universe trillions of years ago and in the trillions of years to come. Yeah? If there was life after death, by definition, all parasites, small animals, dinosaurs, and bacteria would also have to exist sitting at God's side. I think that says it all, but believers would not be amused. Yeah, life after death is an oxymoron because what you're saying is the person didn't die. You're saying the person now has a different form, but he's still moving around, moving his arms, legs. He's talking, he's listening, So how dead is he? Is that the definition of dead when it moves like the ghost there, So, yeah, there is no such thing as life after death. Now, the person says, well, because then what you're really saying is the person never died. He just transformed, from a bodily, piece of meat into a ghost, bed sheet, I guess. I mean, I don't know what a ghost is, what a spirit is. The soul, concept, thinking, goes to heaven. What is that? Is there a matrix up there in the sky and you form part of the matrix and your soul just lives forever? I mean, you have to define these things if you're going to talk sensibly, and there's no way you can. There's no such monster as life after death, simply because, like this fellow says, it's an oxymoron. Life is life, and if you died, you can't say you're alive. You're still alive because then you never died. Okay, we have a weird world today, a crazy world. Here we have this girl, right? And she's made by AI. That's what it's called. What? Aitana, right? Lopez, right? An agency created an AI model who earns up to $11,000 a month because it was tired of influencers who have egos. So they created this image, and it's, I guess you can say Photoshop. That's the best way to explain it, right? And yeah, we get this world where these, lots of people follow these things, and they say, oh, I'm going to look at these AIs that they created, and they create them with Photoshop, and they send their money in because, they're maybe affiliated with something out there, and or just the hits or whatever. And so these people are making money with images. And here are these guys at home, and they're just watching these things and saying, oh, look how beautiful that AI is, that robot, that image is. It's not a real image. It's one manufactured. So we do have a crazy world, believe me. Okay, final issue, a fellow says, does money exist if it's not an object? When money is no more, humans become extinct, okay? Does money exist right now in our present society? Does trade exist if money does not exist? And I answered this fellow the other day, but he came back with the same thing. I guess he didn't understand. So I don't know if I can, rub it in one more time. Exist, object plus location, right? You need an object to talk about existence. Otherwise, you cannot, in physics, in rational science, in the only science that there is, really. In ordinary speech, you can say whatever you want. You can say love exists. You cannot say love exists in science, okay? Because science requires that exists have an object. There has to be a thing there in order to talk about existence. You cannot say that mass exists, or that energy exists, or that field exists, or that charge exists, or that a wave exists, okay? No such monsters. All these are concepts, okay? Mathematical concepts, especially, So exists, you need an object. And so, again, he goes, money and trade. But money is a static concept, right? Forget about static or dynamic. Both of these, money and trade, are concepts. So in science, in physics, right? You cannot say that a concept exists. Any concept, doesn't matter which one, okay? And so I don't know how to get through to this guy. You need an object. You need a thing. You need a table, you need a chair, you need a ball, you need the earth, you need a human. Then you can talk about existence. So if God wants to exist, he needs to choose whether he's an object or a concept, right? If he's a concept, then he doesn't exist. So you got an oxymoron there. But the only way God can exist in science is if God is a thing with that has shape, that which has shape. So then God, you can say, exists. At least if he's got location, but only under those conditions. Otherwise, you cannot say God exists, because if you're going to say God is intelligence, God is love, God doesn't exist by definition in science, in physics, under the definition we have in science. If you're going to go with a definition, the nonsense definition that they have in ordinary speech, which is a non-definition, no one has ever defined the word exist, then yeah, you can say anything exists. You can say love exists, God exists, whatever. Spirits exist, everything exists, soul exists, not in science. In science, it's got to be a physical object. So you can't say conscious exists, not in science. Okay, and so in physics, it's irrational to say that a concept exists, okay? When you suggest that money or trade exists, you are using ordinary speech, okay? Ordinary speech is outside the bounds of physics, outside the bounds of science. In science, we define our terms so that we can use them consistently and we can make ourselves understood by someone who's listening, an intelligent person who's listening, you can't use this term exist for concepts. And when you say money or trade, you can say that gold exists. You can say the paper, the bill, right? That exists, right? You cannot say that money exists, because money's here, not out there. And money is not a thing unless you make it into a thing and confuse it and say the dollar bill is money. No, the bill is one thing. Money is the value you give the dollar bill. Okay, so money is the concept. The bill is a thing. The bill might exist if it has location. Money never exists, because money is something you give value to and you're willing to exchange, trade. Okay, so let's keep the concepts separate from the objects. Okay, so let's move on to our main segment of today, which is spin. Okay, and the question is, what is spin? And the other day we left off with this gentleman. His name is Richard Feynman. And they asked him, what is spin? He could not tell us. He had no idea what spin is. He was a Nobel Prize, I think 1965. We got his Nobel Prize for QED and quantum electrodynamics. And he invented this space-time diagram, all this nonsense that they have in quantum mechanics. But he could not tell us what this feature, which has been around at least since the 1920s, if not earlier, called spin. They were thinking that electrons spin, especially the electron, right? And so they were thinking it was like a top. They said, okay, top spins and the electron spins, okay? So that was the original thought, and the word stuck. They said, okay, spin, right? Turns out that they eventually discovered that spin is not spin, okay? that spin is not like, what you have with a little top, right? And so then what is spin? Because they could have changed the name if they found out it was something different. If it was, I don't know, torque, you would call it, okay, we were wrong. It's not spin, it's torque, for example, right? Or jumping up and down or whatever. They said instead the electron doesn't spin, it jumps up and down. Okay, great. But so what is spin? If it's not spin, like a top, what is it? And of course, since good old Feynman, he was in the 60s, you can say, well, we've evolved since then. That was 60 years ago. Okay, so let's see what spin is today. We have this gentleman. His name is Matt O'Dowd. Okay, and he asked the question, what is spin? Okay, and so how does he answer it in general terms? Well, he says, we've established that quantum spin is very weird. Man, that's a very bad way to start a presentation, because when he says it's weird, he's not being truthful. He's saying they're ignorant. They have no clue. That's what he's saying. But he says it's very weird. That's not the right way to put it. Okay? You got to say you're ignorant and you don't know what spin is. That's the correct way of saying, not weird. Okay? Because if it's just strange, you would say, well, it's not the spinning of a top. It's like jumping up and down or torquing or something else. That's not what he's saying. He's saying we don't know. Okay? And says electrons have spin but aren't really rotating. No one understands quantum spin. Right. So don't tell me it's weird. Tell me that you don't know. Okay. Weird means that, in the language of mathematics, when they say, there's a paradox, it's weird, means that they don't know squat. That's what they mean. Okay, that's what they're telling you in your face. And then you have people who listen with half an ear and they say, they really know, because otherwise computers wouldn't work. Yeah, tell me about it. Okay, computers wouldn't work, but quantum says that a particle can be at two places at once. Is that why computers work? Or is that what computers prove, that a particle can be at two places at once? That's the explanation they give. When you put them against the wall and say, but that's nonsense. How can a particle be at two places at once? Well, we don't understand, and we don't care about that, because that's philosophy, or philosophy of physics, philosophy of science. What we do is math. We do equations. Okay. So why did you even attempt to give me a physical interpretation, right? If later on you're going to tell me, well, we don't understand it and we don't care about that anyway, it's not in our job description, we don't do those kinds of things, that's philosophers on the other side of campus. So why did you try to give me philosophy, right? Philosophy of science, philosophy of physics. Why did you even attempt to give me a physical interpretation if you're going to give me a nonsensical one and then say, well, we don't care about that anyways? You should stick to math. If you're going to do math. Don't jump the fence into physics. That's the issue. Okay, so what does he say? Well, here Mr. O'Dowd says, this is spin, and there you can see what he's doing. He's really spinning that cube, right? And he's suggesting that there's this field that is being torqued all around, the cube there, but the cube is spinning. I want you to focus on that. He says spin is not spin, but he is illustrating this as spin. You can see the ball there is spinning, okay? And so he's saying, well, what it does, it kind of torques the field around it. Okay, great. We don't know what those lines are, those ropes, those, cables, whatever those things are, right? These strings. Okay, but he says they come all the way to the electron, and so the electron is spinning and twists these things around. And so what are those lines? I mean, I don't see them in the standard model. What are those lines that he just put in there by hand? He put them in there, he doesn't explain what they are. He doesn't tell you, like, oh, by the way, those lines there, they're this, they're strings, or they're, what are they? He just puts them in by hand, saying they're attached to this thing that's rotating, spinning, right? Rotating around its axis. And if it's rotating around its axis, yeah, it is spin. So he's saying, we don't know what spin is, but I'm going to illustrate it as, like a top would spin, right? He illustrates it like this, He illustrates it like that, but then he says, that ain't so. And don't take what I just showed you literally. But then he does spin it. He spins the cube, he spins the ball, right? And and so you say, well, what does your atom look like? Does it have all these little strings attached to it or whatever? No, this is his atom. He shows the atom, okay? And it's the standard model that you'll see out there, the planetary model. That's what they always show. Okay? They show a ball in the center, which is supposed to be the positive proton, and the electron, somewhere around the proton. And the white line there going around, that's put in there because it suggests to you that the electron is going to go, that's the orbit of the electron. And they call that line an orbital, orbital, or you can call it an energy level, whatever they want to call it. But they always put that in there to suggest that the electron always goes around or somewhere around the proton. Okay, so this is the official atom. And when you say, well, is that the atom, the quantum atom? That's when they say, well, no, it's not. You're not supposed to take it literal. We don't know what an atom looks like, they say. Okay, but they always illustrate it as a planetary model. We've inherited that from good old Niels Bohr and Rutherford, Ernst Rutherford. Okay, we have another guru. His name is Derek Muller, and he's confirming what this other fellow, Matt O'Dowd, said. He shows electricity here. And what is he showing? He's showing a positive proton, right? And the negative electrons moving from proton to proton, from atom to atom. So he thinks of electrons as little beads that flow, and he calls that electricity. In fact, he says a copper wire consists of positive metal ions swimming in a sea of free negative electrons. If there were a current in the wire, the electrons would just be what? Drifting in one direction. So he's saying that electricity is what you see there, the flow of electrons, many of them, from atom to atom. And so this assumes a planetary atom. So the planetary atom is confirmed. It is the official atom of quantum, which is subsequently denied. Okay, they deny this atom. First, they show it to you. They say this is what an atom looks like, a little bead going around. This is what electricity looks like, the flow of electron beads from atom to atom. And then at the end of the show, they say, by the way, all we talked about today, forget it. None of it is true. We have no way of illustrating. We have no idea what electricity is. We have no idea what an atom looks like. So they illustrate it, and when you call their bluff, they say, oh, by the way, that's philosophy. Okay, but yeah, here you have the atom, okay, that good old Rutherford and Bohr invented. And that's the one we use today. You have the electron bead jumping from energy level to energy level or orbital to orbital, and it's somewhere around. It doesn't have to be a planetary sense in the sense that it has a fixed orbit. It just goes back and forth. It's somewhere around the proton. That's the only change they made to the Rutherford-Bohr atom. Okay, but essentially it's electron bead negative, right, which is somewhere next to the proton center, positive proton center. And so the question is, why doesn't that bead, the blue bead, the electron bead, why doesn't it spontaneously drift away, or why doesn't it spontaneously fall into the positive nucleus? Because if it's negative, you would think it's attracted by the proton, right? And so they never explain that. They don't know what keeps the electron faithful to the nucleus. And that's the whole issue. They've never answered the question, which was how they started this issue. They started talking about the atom, the beginning of the century as a planetary atom. It came, some studies by Bohr originally and then by Rutherford, primarily those two. And they eventually concluded that it's this planetary atom, and we've never gotten away from that. We always represent the atom as the orbit, as the planetary atom. Okay, and then obviously then that's when they deny it. Okay, so here we have the Wikipedia, and this is what Wikipedia tells us about spin. Spin should not be conceptualized as involving the rotation of a particle's internal mass, meaning, a top spins. That's not what they're saying. As ordinary use of the word may suggest, spin is a quantized property of waves. Oh man, the waves are spinning. And what are waves? Well, there are a bunch of vectors. That's what a wave is. If you look at especially the electromagnetic wave, all those arrows, those engine arrows that they illustrate, those are vectors. What's a vector? Is it an arrow like an engine arrow? No, it's magnitude and direction. Okay, so especially magnitude. Okay, the very earliest models for electron spin imagined a rotating charged mass. But this model fails when examined in detail. The required space distribution does not match limits on the electron radius. The required rotation speed exceeds the speed of light. Okay, that's why they figured out that spin is not spin, okay, like a top spin, because it would violate some cherished laws of mathematical physics. The classical analog for quantum spin is a circulation of energy. So now we have this thingy called energy, which is a mathematical concept. It's just a number followed by a unit. That's what energy is. You can have I used to work with kilo electron volts. The big accelerators, they work with giga and maybe even tera electron volts. Okay, so they're talking about a concept, a mathematical concept. That's why they say the circulation of energy. How can a mathematical concept circulate? And yeah, they use these euphemisms, and that's why people don't understand a lot of this stuff, because it's not like kindergarten stuff where you get a block and you say the block moved from here to there. They can't do that with quantum. What they do is they talk about math. They say, oh, we have this number plus a unit, and it circulates. Or momentum density in a particle wave field. A particle wave field. Particle is not a particle. Wave is a concept, and field is a concept. So far we have nothing in front of us. We have a mathematical concept. Spin is essentially a wave property. Yeah, meaning it's a mathematical property. Spin belongs to physics, whereas wave belongs to math. And never the twain shall meet. As the name suggests, spin was originally conceived as the rotation of a particle around some axis, right? Like the top. Historically, orbital angular momentum related to particle orbits. While the name based on mechanical models have survived, the physical explanation has not. In other words, they kept the word spin, but it ain't spin. Quantization fundamentally alters the character of both spin and orbital angular momentum. Since elementary particles are point-like, right? They're point-like, meaning they're made of a single piece. That's what they're trying to say there. Okay, point-like means it's not made of any particle. It's an elementary or fundamental particle, meaning it doesn't have parts. Self-rotation is not well defined for them. No, it's not that it's not well defined. It's not defined at all. You cannot talk about rotation or spin or anything of something that is conceptually made of a single piece. Okay, not even God can rotate that which is made of a single piece, because you would have to have at least 2 points within that object, right? For example, a point on the outside, a point on the inside, right? And you can say, okay, this point rotates or spins, with respect to this one. You don't, because it's a single particle. There is no second point to it. Okay, and this is the problem with using a fundamental particle and talking about spin. There's a contradiction there. Okay, they say, well, we cannot exactly tell you. No, it's not that exact. You can't. It's impossible. It's irrational to try to say that a fundamental particle spins, period. Okay, so don't talk about spin, which is a physical property, and you apply it to this thingy, which is not even a particle, which is a concept. Okay, an abstract mathematical concept. It's a number. That's all they see. Okay, they talk about the mass, the charge, right? 1.6 times 10 to the minus 19 coulombs. That's what an electron is for a mathematician. It's a number followed by a unit. Okay, it's just a relation with respect to other constants or things that they've measured and established there. Okay, so here we have another fellow. His name is James Lincoln, and he's from UCLA, and he's going to show you what spin is. He says spin, but then he illustrates it is spin. There you see him moving his hands. Okay, so they say that spin is not spin, and they all illustrate spin as spin. There you see him. What is it doing? Spinning, right? And he's saying that, and there he shows it. He's twirling it, right? Okay, that's how he's saying that the electrons orbit the nucleus, but you can see how he's going to spin them. Okay, so this is the issue. The issue is that all these people have a contradiction, and that's because they cannot picture anything in the quantum world. They say electron is a particle. It's a elementary, fundamental particle, meaning it's not made of anything, meaning it's made of a single piece, right? That's what they mean. And then they talk about spin, about rotation around an axis. This is a mathematical concept. You can't do that with a particle that is made of a single piece. It's got nothing to rotate around. There is no, you can't divide it and say, well, I'm going to put an axis and I'm going to put a point on the outside of it and say that the point rotates with respect to the axis. Not for a particle that's made of a single piece, because you're in effect saying it's made of at least two pieces, a centerpiece and an edge. And you're violating your hypothesis. Your hypothesis was that it was made of a single piece, remember? And now you're saying, no, it's made of two pieces. One on the outside, one on the inside. This one rotates around the inside. You can't do that because you get a contradiction. Okay? These people don't understand these things because they never do physics. What they're thinking about is math. They're thinking about equations. They're thinking about numbers and units. They're not thinking about physics. They're not picturing. They're not visualizing what they're saying. Okay, so here we have, let's go with electron spin the way the mathematicians do it. Okay, here it is. Here you have an electron, and it's supposedly made out of a single piece. I color-coded it just so that you could see spinning of a particle made of a single piece. You got to think of this thing as made of a single piece, even though I color-coded it so that you can see the spin, okay? So that's our starting point, okay? Here we have it rolling around the proton, okay? That's your hydrogen atom there, okay? So we have the little ball on the outside. It's spinning, right? And it's also rotating or orbiting the proton, which is also, I guess, spinning, right, around an axis. Okay, so that's the situation. And that's their atom. Okay, that's what they imagine, this planetary atom. Okay, so keep that in mind. This is how they picture these things. And so the question is, okay, let's concede, because see, this Lincoln guy says he can explain magnetism, right, with this electron spin. He says, oh, we discovered that every time that there's attraction, it's because the electrons on each of the two magnets that are attracting each other are spinning. Okay, let's concede. Okay, so they spin. Okay, so the electrons are spinning. Tell me how the spinning of the electrons in each magnet cause attraction from a distance. Okay? And here I try to illustrate it for you, okay? Yeah, you have the electrons going around their protons, and we illustrate this as hydrogen atoms, obviously, right? Because we're trying to simplify, we're trying to get the mechanism only. Okay, so they're spinning and they're orbiting their respective protons on two magnets. Why or how, by what mechanism does one magnet attract the other now that we have, your electron spins? Okay, just tell me that every time that a magnet attracts another, you notice that the electrons are spinning and they're orbiting their atoms. Fine. And that they're all aligned, no problem. Tell me how this produces attraction from a distance. Okay, and this is the problem. The problem is that they give you a description, but not an explanation. They cannot tell you how the electrons do this from a distance. Here we have two magnets, right? Little guys there, the two dark ones, okay? And so the question is, here the electrons are spinning for each one of the magnets. Okay, great, no problem. I'll concede. Okay, and so the question is, why is this already pulling on me from a distance? I mean, the electron stretches across that divide. So this is the problem. The problem is they cannot explain the mechanism, and they say that's philosophy. We don't do that. And if you don't do that, why did you even try? Why did you try to convince me that with electron spin you can explain attraction between two magnets? You can't. You can't, because you can't do it with discrete particles, which ain't particles in quantum physics. They're just values. They call them particles, but they're values. That's all they are. They're numbers. They're numbers followed by units. They're talking about energy and charge and fields and mass and nonsense that has nothing to do with physics. In physics, you got to have the object. If you're going to talk about balls, okay, tell me how a ball attracts another ball from a distance. And the answer is you can't. You need to have some connection there, physical connection. And you say, Bill, why do you say that there's a connection there? I can't see or touch anything in between. I can't see or touch the mediator. And the answer is very simple. The answer is that if you don't put a mediator in there, you're doing so-called physics with black magic, with, witchcraft. That's what you're saying. You're saying that you're going, ooh, and it happens. It does happen no matter what. You're doing it with black magic. And so this is the problem. You have to put a mediator in there, a physical mediator that you cannot see or touch, because a mediator is not that which you can see or touch. It's that which has shape. There's something there, elongated thing, uniting these atoms, right? And we can't see or touch it. You have to arrive at a different hypothesis, a different starting point. And then you can start explaining things, because you don't need magic now. You don't need to say, well, this particle, discrete particle affected that discrete particle from a distance. You can't say that, not in physics. You can say that in religion, but not in physics. Okay, so here we have a spiraling atom. Someone sent me a question there, or says, if all atoms in the universe are connected, what happens to those gazillions of threads in a rotating object like a star or a planet? Do they stack up indefinitely? If so, the objects would gain mass and volume. It would be like a snowball picking up more snow and getting bigger as it rolls down a hill. So this fellow, again, he's thinking in terms of see and touch. That's the whole issue. They say, well, if this wraps around, it means it's touching, right, the thread and just rolling it around. Okay? And so this is the first problem here. Okay, here, let me show you. The definition of the word object destroys all religions. I say that. Okay? Okay, that's the first issue. And the second issue, an object is not that which you can see or touch. Okay, so whenever you use the notion of see and touch, that's when you're going to run into trouble. You got to get rid of touch. Don't bring see and touch into physics, okay, because it's not about see and touch. An object is that which has shape. All objects have shape in the universe. All objects, all atoms have shape. What not all things in the universe are not. They cannot all be seen, and that cannot all be touched. You can't see the air. It's made out of atoms. You can't see it. Imagine the ropes that connect, two atoms, which is gazillions of times thinner than, the diameter of an atom. And so, you got to put it in that context. You can't see or touch. You cannot bring the see-touch criteria and try to debunk, the rope model. Besides, we don't care about debunking. There is no debunking in science, really. In science, you criticize and you explain, and it's the explanation part that forms a part of science. Criticism, you can criticize. If you have a good argument, you can try to destroy a theory and say that's not correct, that's in violation of Mother Nature, right? But hopefully you can put something in exchange, because if you do not explain, if you do not propose something in exchange, you're not a scientist. A critic is not a scientist. A skeptic is not a scientist. The scientist is the guy who explains. Okay, so let's get that right. We don't debunk. Okay, what we do is we criticize, but propose something in exchange to replace it, to say, I'll tell you why yours is irrational. Okay, it's not that it's wrong, it's irrational. And especially in the case of mathematical physics, if you're going to be moving concepts around, like mass and charge and fields, well, then, we need to take you in with the men with the white jackets. We do not move concepts in physics. Physics, you have to have objects, and you have to have a replacement for what the other guy proposed. You're not the critic who's in the crowd watching the fight. You're the boxer who's inside the fight. You're the guy in there. That's the scientist. Right? Shape is a universal property of object. There is no object you can imagine that doesn't have shape. Concepts don't have shape. Okay? Not a single concept has shape. Okay, but if you know of any concept that has shape, man, let me know. Okay, so here we have a simulation to try to show you how an atom looks like under the rope model. Okay, and this was made by my good friend Dan Ferguson, right? Took the trouble to draw that atom there in the center, and I've used that quite a bit, so I thank him tremendously for his job, right, for his work. Anyways, here we have the atom. That's more or less what we think the atom, hydrogen atom, looks like. Okay, we have a star in the center, that's the proton, and it's surrounded by this membrane, which is weaved by countless threads, not ropes, threads, okay? And so we have the threads making the star and the threads making the membrane that encapsulates the star. And then what comes towards that are ropes, not threads, but ropes, twine threads, okay? So we have ropes coming towards the edge of the atom. They fork out. One goes to the center and becomes, the blue ones in this case, right, goes to the center and becomes part of the proton. And the red ones, they weave around and they form the membrane that encapsulates the proton star. There's no positive, there's no negative. We don't know what that is in physics. Mother Nature has no clue when they talk about positive and negative. Okay, okay, so that's our atom. Okay, that's the one we propose. Okay, we're saying that it's not the planetary atom, it's this atom that you see there. Okay, and here we have okay, I don't have it. I was going to show you quantum jumping. I just want to show you that that same atom expands and contracts. Okay, and so keep this in mind for this notion of spin. Okay, so it's going to expand and contract. Is the electron spinning? Electron shell, is it spinning around the proton star? That's the question. Okay, do electrons spin? And we're not talking about a little bead that's on the outside, elementary particle that is moving around, spinning. We're not talking about that. We're saying the electron is a membrane. And whenever they talk about the bead, what they're really pointing to is a location on the membrane. Okay? So that's what they've confused for the electron bead. Okay, but we have this. Does the whole thing rotate? Does the electron, the whole electron membrane spin around, the center axis? And my guess it doesn't. Okay, and again, I'm making the assumption that it doesn't. You have to think of it more or less like this. Okay, what it's doing is you have all these threads, right? What we call the magnetic thread, arbitrarily using the word magnetic just to be consistent with the past, so that we don't change the wording. We try to keep as much with the wording as possible, so we use the electron thread to make the proton star, and we use the magnetic thread to make the encapsulating membrane, balloon, right? But this balloon is not a smooth balloon. It's made out of threads. The threads are not, stretched out in the sense that they're, straight or smooth. They're corrugated. They're bent a little bit all around. Okay, And what you have is this thread which is torquing all around the electron shell. So all these threads are wound around the electron shell, and they're corrugated to some degree. They're not in a straight line, and they're twirling in situ. Okay, so when they measure or they detect the electron at a given point, the electron shell at a given point, they say, oh, the electron is spinning. No, it's not spinning. What it's doing is moving around, like more or less. I'll do it with a rope. It's not exactly this, but it's doing this, in situ. It's just moving around in situ. Okay, that's what it's doing. And so it's not that the shell rotates, but that the electron thread is going all around, the magnetic thread, is going all around, and it's twirling in situ. Okay, and this gives a sense that there is motion of not only locally of the electron bead, right, quantum mechanics, but also of the whole shell. Gives an idea that the whole thing is maybe spinning or rotating. And I don't think that's the case. I think that the reason there is such speed in the spinning of the electron is because it's going nowhere. It's doing it in situ, just moving around, at great speeds, perhaps at the speed of light, and so they say, oh, it's spinning. But we don't know what spin is. And it's a wave property. Yeah, it is a wave property because we're talking about a little thread that has a waviness to it, and it's spinning in situ. And that's why it's so fast. It goes all around and also in situ at a great speed because that's how fast it's moving. Okay, and this is probably the best way to picture it. So, okay, so that's my take on that. I can say that, here's maybe a couple more that you can ponder so that you can try to visualize this. Here it is. Okay, here's, you can imagine the ropes converging upon this ball, and the locations that you see there, they're not moving. The thread, that piece of thread is not moving really. What it's doing is turning in situ. It probably moves a little bit anyways, forward or backward, but primarily it's spinning in situ, and that's what gives them the idea that there's an electron spinning locally, and that it's made out of a single piece. It's infinitesimally small, right? Because that's what what's in front of them, but which they can't see. This is something you have to imagine, you have to visualize. We'll never be able to see this stuff. It's just for food for thought. It's for you to comprehend it, understand it, and say, well, maybe that's the way it is out there in this secret world of Mother Nature's atom. And that's the best we can say for spin. Okay, with that, we'll see you next week. And I hope you stay healthy and